Assalamualaikum and hi everyone. I'm teacher Iman Nafisah. Welcome back to my video lesson. For today's video, we are going to learn generation of electrical energy in a nuclear reactor in 15 minutes. So this is going to be the last video for nuclear physics. Today, we are going to continue chapter 6, nuclear physics. And before this, we already covered nuclear fission, nuclear fusion, and also some problem solving involving nuclear energy due to radioactive decay and nuclear reaction. And now we will continue 6.2 nuclear energy. And our learning outcome is 6.2.4, which is describe generation of electrical energy in nuclear reactor. Today's video are divided into some parts. And for the first part is structure of a nuclear reactor and the process of generating electrical energy. When a country wants to generate electricity by using nuclear energy, they need a nuclear power plant or nuclear reactor. This is the example of structure of nuclear power plant. In here, we have containment structure, which is we have reactor vessel and control rods. Also, we have condenser, turbine, and generator that will be used to generate electricity. And now I will explain part by part into the details. The process starts in the reactor vessels, where nuclear fission of uranium-235 happens and its chain reaction will produce heat energy. This uranium-235 comes in the shape of pellet and are arranged in a metal tube. There can be a lot of uranium-235 in a reactor vessels, depends on the size of reactor vessels. Sometimes it can fit to thousands of uranium-235 in one reactor vessels. So, let's watch this video for better understanding. This is the example of uranium-235 in the form of pellet, and it will be arranged in a metal tube. Okay, let's watch this video.
That process into small pellets. Then the pellet are sealed into metal tubes, which are welded to form a fuel bundle. The fuel bundles are then inserted in a large tank called calandria, which is the heart of the nuclear reactor. Typically more than 200 of these rods are bundled together to form a fuel assembly. A reactor core is typically made up of a couple of hundred assemblies. In order to allow
Okay, every chain reaction of uranium-235 will produce heat and makes the temperature of reactor vessels higher. That's why the next process, the water will be pumped into the reactor core to absorb the heat energy that is produced by the nuclear fission. Then, the boiling of water will produce high pressure steam. This one is high pressure steams, and this steam will be channeled to the turbine. And what will be happen to the turbine? What actually happen is the turbine is rotated by that high pressure steam, which in return will rotate the magnet or coil in the generator, and the steam will condense into water. So what happened to generator? After it rotates the magnet or coil in the generator, then the electrical energy generated is sent consumers via a power supply transmission system. Yay! So we have already generate electricity. The second part for this video is chain reaction of uranium-235, which is the radioactive source used to generate this nuclear energy. But first, we need to recall what is nuclear fission. In previous lesson, we already learned what is nuclear fission. By definition, nuclear fission is a nuclear reaction when a heavy nucleus splits into two or more lighter nuclei while releasing a large amount of energy. So, it can simply like this, where we have an incident neutron bombard into a nucleus, and the nucleus will be unstable and will be split into two or more, and it also will release some energy with three incident neutrons. Okay, this is what happened in nuclear fission, and now we will relate it with the uranium-235. Okay. Okay, this is the chain reaction of uranium-235, where you can see we have neutron that will be bombarded into uranium-235 and make the uranium-235 to become unstable and will be split into two. And it will be produced barium-141 and also krypton-92. This reaction only occurs for one uranium-235. Remember, in one reactor vessels, we can have thousands of uranium-235 and we will have thousands or more chain reaction of uranium-235 in the reactor vessels. Okay. This is just the example of chain reaction of uranium-235. Okay, and then we will move on. The third part is control of rate of nuclear reaction and also safety features in a nuclear reactor. The reactor vessels need to be controlled so that it can function well. We have two control of rate of nuclear reaction, which is the first one is control rate. The control rate is to control the reaction rate by absorbing excess neutron, and it is made from materials such as graphite or water. And the second control is moderator, which is it will slow down the reaction rate by absorbing excess neutron. It is made of boron or cadmium. Then, for safety features in a nuclear reactor, we have thick concrete walls. It is to prevent radioactive radiations from leaking into the surrounding, and this is good one. And the second is water as a cooling agent, which is it will absorb heat energy from the chain reactions to generate steam. This can be control the reactor temperature. And the last one is uranium rod that used as fuels for producing nuclear energy through nuclear fission reaction. The last part is the use of nuclear energy as an alternative source to generate electrical energy. Let's go. Actually, for your information, we have variety of source of electricity that we use to generate the electricity. Okay, we have coal, we have petroleum, we have natural gas, we have nuclear that we just learned, we have hydroelectric and others. So, the question is, what is the source of electricity that Malaysians use to generate electric? Yes, first we use coal. Second, we use hydroelectric. And the third one is it nuclear? No, we use natural gas. We have one reactor in Agency Nuclear Malaysia, but we doesn't use it to generate electric. It just for the purpose of research. So we use these three sources. Okay. This is hydro dam in Bakun, Sarawak, which is used to generate electricity. The source is hydroelectric, and the table here is the other power plant used to generate electric. Okay. Okay, there is a lot of countries that use nuclear energy to generate electricity. This source is from the World Nuclear Industry Status Report in 2021. The countries with the most nuclear reactor is from United States. It has 93 nuclear reactors and followed by France, China, Russia, South Korea and others. Okay? So now let's answer some question. We have two question only, and this question is to evaluate our understanding. Either you understand or not our lessons today. So we will start with question one first, okay? Okay, question one is explain how a nuclear reactor generates electrical energy. Okay, first, nuclear fissions of uranium-235 and its chain reaction produce heat energy. And then after it's produced heat energy, what happened? We need to use water to pump into the reactor core to absorb the heat energy that is produced by the nuclear fission. Then, what happened to the water? It will boiling, and the boiling of water will produce high pressure steam, and that steam will be channeled to the turbine. And what happened to the turbine? The turbine will rotate by the high pressure steam, which is in return, it will rotate the magnet or coil in the generator. And the steam will condense into water. And then what happened to the generator? The electrical energy will generate and then sent to the consumer via a power supply transmission system. Okay, this is how a nuclear reactor generates electrical energy. You just need to remember these 5 processes only. Okay? Okay, then we will go to the next question. Okay, question 2, which is the last question, is what is the fission product of uranium-235? Okay, we recall back nuclear fission is a nuclear reaction when a heavy nucleus splits into two or more lighter nuclei while releasing a large amount of energy. So here in this diagram, we can see that neutron bombard with uranium-235, but we don't know what is this and what is this one. So, do you have any idea what is the daughter or the product fission of uranium-235? Okay, actually the first one is barium-141 and the second one is krypton-92. This is the fission product of uranium-235, and then the process will repeat it. Okay, that's the last question. Congratulations for answering this correct. Okay guys, that's all for the video lesson about generation of electrical energy in a nuclear reactor. I hope you gain something and thank you for watching. Bye.